Discovering the fossilized skull. Paleontologists from Flinders University have unearthed the most complete fossil of the prehistoric Thunder Bird Genyornis newtoni in Australia's Lake Callabonna Fossil Reserve. This groundbreaking discovery provides an unprecedented glimpse into the appearance and lifestyle of this giant, flightless bird that roamed the continent over 45,000 years ago. Find of the century. For over a century, researchers have struggled to find a complete skeleton. In 2019, while excavating in South Australia, the team unearthed a mostly complete skull of this extinct creature, providing new insights into its appearance and lifestyle. These findings have been published in the journal Historical Biology. The remarkable skull structure. The skull is a marvel of prehistoric biology. Weighing roughly 5 times the weight of a southern cassowary, Genyornis boasted a massive brain case, large upper and lower jaws, and an unusual casque atop its head. The upper beak displayed a surprising morphology, setting it apart from its closest relatives. Traits of other birds. Genyornis newtoni had a tall and mobile upper jaw like that of a parrot but shaped like a goose, a wide gape, strong bite force, and the ability to crush soft plants and fruit on the roof of their mouth. What did the Thunder Bird look like? The Genyornis newtoni, also known as the Thunder Bird, stood more than 6 feet tall and weighed up to 500 pounds. Contrary to previous beliefs that it resembled a prehistoric emu, the new skull reveals that G. newtoni was more akin to a giant goose. Diet. The beak was long and goose-like, suggesting the bird primarily fed on soft leaves, fruit, and aquatic plants. With this new skull, we have started to piece together the puzzle which shows, simply put, this species to be a giant goose. Reconstructing the past. Using modern birds as comparatives, researchers reconstructed the head of G. newtoni, gaining insights into how the bird functioned. Bringing fossils back to life. The form of a bone and structures on it are partly related to the soft tissues that interact with them, such as muscles and ligaments. We are able to put flesh back on the fossils and bring them back to life. Unusual adaptations. In addition, the study revealed several unusual adaptations for aquatic habitats, suggesting that G. newtoni was adept at protecting its ears and throat from water influx when submerged. These adaptations further support the classification of Genyornis as a giant prehistoric goose. Features of its beak. Analysis of the fossilized beak remains revealed several unusual features. The beak's shape indicates G. newtoni was adept at feeding in water, even though it lacked a duckbill or webbed feet. They also interestingly have features that allow them to open and close their jaw underwater without impacting their hearing or water going up into their palate or nose. The extinction of the gigagoose. Researchers believe that weather changes and human activity contributed to the extinction of Genyornis newtoni. Around 45,000 years ago, freshwater lakes in Australia began to dry up, and early humans likely used the bird's eggs as a food source. Implications for extinction. The combination of habitat loss and hunting pressure led to the eventual demise of this giant bird. They are a truly unique Australian island experiment, as unique as koalas and kangaroos. A breakthrough in understanding prehistoric life. The discovery of the G. newtoni skull marks a significant milestone in paleontology. It provides researchers valuable information about the bird's morphology, ecology, and evolutionary relationships. McInerney and her colleagues plan to further analyze the gigagoose inner ear to understand how the bird moved across its prehistoric landscape. This research opens new avenues for exploring the behavior and adaptations of this unusual species. Future research directions. The discovery of the complete skull opens new avenues for research. Future studies will focus on analyzing the inner ear bones of G. newtoni to understand better how these birds moved and maintained balance. After 128 years of exploration, fossil excavation, and investigation, we finally have a comprehensive understanding of what Genyornis newtoni looked like. This discovery reshapes our understanding of these magnificent prehistoric birds and their place in the evolutionary history of waterfowl. Looking forward. The remarkable findings from Lake Callabonna not only illuminate the past but also inspire further exploration and discovery in the field of paleontology.